Hello, I am Noura Al-Hussein. In this video, I will talk about aliasing and anti-aliasing in digital image. What is the meaning of each one of them? Starting by the introduction, moving to sampling theorem, aliasing and anti-aliasing in images. Finally, of course, there will be a reference. If you don't know that, a digital image is a two-dimension function, fxy, where x and y are spatial coordinates. The amplitude of f at any coordinate xy is called the intensity of the image at that point. When xy and the intensity values of f are all finite discrete quantities, in that time we call the image a digital image. Pixel is the way for the computer to understand the image. Also, it is the element of a digital image. Moving to sampling theorem. Also, we can say Nyquist-Shannon theorem. Could you please focus on that condition? It's very important. Sampling frequency, also we can say sampling rate, must be larger than or equal to twice of the highest frequency. As you see here in this figure, sampling frequency is greater than maximum frequency, and here the sampling frequency is equal to maximum frequency. Both of them are getting a good result. What about two dimension? It's similar to one dimension, where function ft, whose Fourier transform is 0 for values of frequencies outside a finite interval, is called a band-limited function. As you see here in these two conditions, what is the delta t and delta z? They are a separation between samples along the t and z axis of the continuous function ftz. By applying these two conditions, we will get an oversample band-limited function. What if we break the condition in one dimension and in two dimension? Of course, there will be a aliasing problem and losing some information from the image. Undersample band-limited function caused an aliasing, and as you see, the red color shows the distortion in both one dimension and in two dimension. Aliasing in the image is a jagged, also called stair-stepping. You can see it more clearly in curves and diagonal lines. When image is resizing, shrinking, and Muri pattern. That image here shows a King Fahd National Library and Al Faisaliya Tower in Riyadh. After I make a shrinking to the original image, I've got a aliasing, distortion. To remove that problem, we have to use anti-aliasing. It's a process which tries to minimize the appearance of aliasing diagonal edges. It's reduced through a blending or smoothing step by applying filtering before sampling, especially using low-pass filter. So the original image moving to low-pass filter, then sampling, that will minimize aliasing. Low-pass filter can reduce the maximum frequency that keep the quality of the image with no distortion. Let's go to the MATLAB. First, I read the image, and then because my image is a color image, I change it to a grayscale, and then show the result with the title. Then I resize the image by shrinking. And you can see here the original one with a high quality, and then shrinking image, it has aliasing distortion. And to reduce that problem, we have to make a filtering to the original image and then making shrinking. As you will see it here, I apply 5x5 average filter to make the image more blurring and smoothing. M filter for the original image and for the smooth image. After that, so here this is the original image. Here, filtering. After that, I make shrinking. Here I make shrinking to the original image and then I make shrinking to the image after filtering, just to see the difference. Here we are. That's the original image. That's the image after filtering. And here, shrinking. Look at the difference. Shrinking before filtering, it has aliasing, distortion, a lot of maximum frequency. And here, we reduce the maximum frequency and getting a good result. If you want to know more details, please go to Gonzalez's book, Digital Image Processing. It's helpful. Also, you can visit the website MathWorks for MATLAB. And thank you for watching.